Having lost its planet status, it would seem that Pluto was no longer on the scientists' minds. Now, just a lifeless, frozen piece of space rock on the edge of our system. But over the last 7 years, just like the icy moons of Jupiter, Pluto proved that it is worthy of attention in the status of an object of interest, the most unique volcano in the entire solar system. Snow that burns, an ocean full of water, a source of heat within the planet. Cosmic smog in the atmosphere, ice mountains, and a bubbling nitrogen glacier. This is just a fraction of incredible discoveries on Pluto, because, as it turns out, there's a possibility of life on Pluto. Although it was discovered relatively long ago in 1930, it remained a mystery for a very long time. Even then, it was clear that this planet, due to its remote location and small size, will require face-to-face time. Take a look at the best picture of Pluto taken by the Hubble Space Telescope in 2006. This was the best we could do, and yet it's difficult to see anything concrete in this collection of pixels. Not long ago, the mating with Pluto finally happened. But first, let's examine what we already know about Pluto before this visit. Let's bring our attention to the fact that Pluto has 5 satellites. The closest and biggest one, Charon, does not actually orbit Pluto, but instead, they move together. Pluto and Charon are even sometimes referred to as a double planet. They orbit the center of gravity between them. This is the only pair of objects in the solar system that interacts in this manner. This is what that looks like. As we take a closer look at the movements of another satellite, NYX, it turns out that the other moons of Pluto move in a pretty chaotic way, which is also unique for the solar system. The New Horizons mission, which commenced in 2006, planned to visit Pluto and take the first proper photographs of it right from its orbit. It appears that Pluto was not in the mood for guests, and at the most crucial moment, the connection with the probe was lost. Thankfully, there's nothing mystical here. The probe system simply wasn't able to withstand the number of commands received from Earth in regards to the maneuvering and photographing of the planet. So, they shut down and switched control over to the reserve computer. You can only envy the enthusiasm and perseverance of scientists. And after 3 sleepless nights trying to reboot the probe before it approaches Pluto, it was a success. The probe began to orbit Pluto, and soon we received these images. And these images were able to see ice mountains, some reaching 2.5 miles. There was also a large number of craters, which is normal since every object in space is subject to being bombarded by asteroids. Did you spot the most unusual thing about these photos? This white area at the center of the planet immediately caught the attention of scientists. It was nicknamed the heart of Pluto, and this heart has an actual beat. It's believed this zone appeared at the site of a relatively recent, by space standards, collision of the planet with an object about 125 miles in diameter a few dozen million years ago. However, there's something unique about this birthmark on Pluto's face. Take a closer look at these pictures, as you may have already noticed. Almost the entire surface around this area is riddled with various craters. Some of them are larger than others, but they are all pretty old. And yet, you won't spot any craters on the white heart of Pluto. This could only mean one thing: this area and its surface, as a result of geological activity during which the crater that formed upon impact was filled with this white substance. Pluto essentially healed its wound pretty quickly. The scientists were able to use a spectrometer to determine it was nitrogen, which is the same substance the snow and mountains photographed by the probe are made of. However, this begs the question: how is it possible that a planet with an average surface temperature of -400 degrees Fahrenheit has nitrogen that could take liquid form and fill the aforementioned crater? This alerted the scientists to the fact that Pluto has a high temperature core. And it's even possible that underneath the icy surface, there's an ocean full of water. After closely studying the patterns on the nitrogen ice, the scientists were able to discern something else. The nitrogen ice at the heart of Pluto is bubbling, not quite the same way as what you see in your kettle, but over thousands of years. Something underneath the surface makes the ice bubble and crack. Studying these patterns made it clear they were caused by the process known as convection. You can observe this process by watching the way clouds form in the Earth's atmosphere. Similar processes take place on the surface of the Sun. Like a fingerprint, convection marks the movement of heat within various substances. And the bubbling ice on Pluto is yet another proof of the heat bursting out from underneath its surface. The next mystery for scientists to uncover was this spot. It looks remarkably like an Earth's volcano, and the texture of the surrounding area resembles the aftermath of volcanic activity. But how would volcanoes form on Pluto? Upon closer examination of these images, it emerged that the substances erupting from this volcano were water. But with the surface temperature as low as this, how is it possible for the water to flow? The answer turned out to be pretty simple. Knowing high school chemistry was enough for the scientists to solve this mystery. If you mix water with ammonia, its freezing temperature is significantly lower. Take a look, and at temperatures close to the surface temperature on Pluto, water mixed with ammonia turns into a thick paste and can flow in a similar manner to lava. It's evident that the temperatures underneath the planet's surface are significantly higher than the scientists can imagine. But where could this heat be coming from? We're used to thinking that our planet is heated by the sun. And this temperature, along with the influence of solar radiation, is the reason our planet retains a huge amount of heat. But that's not the case. Our planet, just like any other geologically active planet in the universe, contains a huge amount of heat under the surface. Although the sun heats our planet to a certain degree, it primarily heats the surface. This heat doesn't penetrate much deeper, even though the solar radiation does reach the inside of our planet. It's precisely the presence of a large amount of radioactive and heavy elements at the core of the planet causes the geological activity and creates the heat within the planet. The scientists assume Pluto would be different. For starters, it's very far away from the sun. Before it was demoted, it was considered the furthest planet of the solar system. The size and density of Pluto also did not indicate the presence of radioactive or heavy elements that could accumulate this amount of heat. The last issue when it came to understanding the temperature on Pluto was the fact that its modest size prevents it from retaining heat. But Pluto proved everyone wrong. So how is it possible for the heat to remain on Pluto? The substance covering the surface of the planet turned out to be more than just ice and snow. It looks like ordinary snow. It's as cold as ordinary snow. But if it were exposed to fire, it would burst into flames. What makes the snow so special? At the temperatures of -375 to 400 degrees Fahrenheit, the water crystals trap a large amount of methane molecules. Like a blanket, this substance shields the warm radiative part of the planet from the cold surface and the influence of the cosmos. This is how Pluto is able to retain heat. Let's move away from the surface for a minute and take a look at this image. The blue haze that you see is Pluto's atmosphere, full of nitrogen. Sure, its atmosphere is not exactly appropriate for habitation because it's mainly composed of nitrogen, has a fairly thin consistency. It doesn't retain heat, and we wouldn't be able to breathe here. Studying the atmosphere, which stretches to 125 miles above the surface, the scientists noted that it has a precise structure and is filled with something resembling smoke. This haze prompted intense arguments, but further research determined that it is smog. But why would there be smog on Pluto? Turns out, there's something else in the atmosphere aside from nitrogen, carbon monoxide, and methane. We're used to the fact that on our planet, smog appears in connection with some form of a burning process. Some of it happens as a result of human activity, but Pluto has no cars and no breathing living life forms. Or does it? Continuing their research, the scientists tried to recreate the composition of Pluto's atmosphere here on Earth to understand what causes the smog. By comparing the causes of smog on Earth and conditions on Pluto, scientists quickly came to the conclusion that this smog is caused by the way the sun's rays affect the gases in the atmosphere. They make the gas molecules break down, transforming them into soot, which subsequently turns into the haze of smog as it spreads through the atmosphere. Under the influence of gravity, this soot falls to the surface, turning into rain and giving the planet its signature brown-red hue. The more sunlight the surface is exposed to, the more red it appears. But the most amazing discovery was the nature of the aforementioned soot. Let's briefly come back to Earth and rewind time to 400 million years ago. Back then, our planet was a water world, with never-ending rain and thunderstorms raging above the surface. The composition of its atmosphere at the time was similar to present-day Pluto. At that moment, the sunlight triggered the same processes as it currently causes on Pluto. In the atmosphere of ancient Earth, breaking down from gas molecules and forming into new, more complex elements, or what we now refer to as the organic basis of nucleosech particles that will go on to form the first chains of nucleic acid and subsequently DNA and live cells, the basis of life. And right now, these elements are falling from Pluto's atmosphere onto its surface in the form of rain. What's more, these elements get into the cracks, and in the process of cryovolcanism, they make their way under the surface, the place that, as we already know, has plenty of heat. Does that mean that this is enough for a life form, however primitive, to emerge underneath Pluto's surface? It's very possible because the icy blanket is hiding an ocean. Upon studying the breaks and craters on the surface of Pluto, it became clear that organic matter does not only make its way under the icy surface, it also rises to the top of it. Take a look at this photo. The red streak stretching from the places where water mixed with ammonia erupted to the surface tell us that plenty of organic matter already formed underneath the surface. Not one is even considered that life on Pluto is a possibility. However, we can already see that this planet is not only geologically active and alive, it has enough heat and is able to retain it. Under the influence of the sun, a sufficient amount of organic bases for life is formed in its atmosphere. Evidently, there are areas underneath the surface warm enough to contain water in its liquid form. Water mixed with ammonia that burst out from the depths of the planet through the volcanoes we've seen earlier suggests that such areas under the surface are fairly ample. All of this is making scientists examine each new picture of Pluto with keen interest. And after the icy moons of Jupiter, it was Pluto that became the new focus of their interest in the search for extraterrestrial life. Having sufficient potential for life to form, Pluto managed to prove that even having lost its status as a full-fledged planet and being demoted to a dwarf planet, it is still very much alive.